of us ever hear of anti-corpuscular rays until flat earthers, and the fact that perspective does play a role with our celestial observations. I mean, that proves it without a doubt that there is a perspective concept, that when we look up at the sky, perspective is playing a role. So like Bob said, then how can an equatorial mount work on a globe? It can't, because perspective should be playing a role there. And how is it accounting for perspective? It doesn't.
Exactly. And to answer the other ridiculous assertion, about who's making fun of her about the Antarctic ice wall, and people are going, well, yeah, show me a picture of the ice wall. It's like, for God's sakes, we've got a zillion pictures of them. I'm showing them to you right now. This is exactly what we're talking about. And this, Captain Cook and the other explorers that have gone down there describe this wall as going on as far as they can possibly see and navigate around, which happens to be around the 60 to 70,000 mile mark as far as a circumference. This is documented history, people.
How long did he take? And he never went below 60 south, right? There's a big difference between the climate in the 60 north, for instance, 60 south. I think 60 north corresponds to 45 south, climate-wise.
Yeah, they're very mismatched as far as the climate characteristics, for sure. And I think he was definitely further than 60 south, because where the Antarctic ice wall itself. Yeah, it's definitely further south than that. But the whole thing is when people go down there, that's one of the things they're in awe of. It's like, wow, these ice walls, thousands of feet high. And of course, Antarctica is also the highest continent, on average of any continent in the world. So where's the ice wall? You're looking at it, people. It's not like it's not there. It absolutely is. And to deny it and say there's no pictures of it, you're delusional, because there are. We're looking at them right now.
Yeah, and it's just the shore of Antarctica. And we've had to say it many, many times, because people do get this idea of there's like an ice wall with nothing beyond it, and nobody can ever move beyond it, Game of Thrones or something. No, it's just the shoreline of Antarctica. It holds in the water. And once you go too far inland, I'm sure it gets too cold and too hard to travel. But we wouldn't know. We're not allowed to go there.
Yep, exactly. But, like I said, the people that have been allowed to go there have gotten footage like this. So this is pretty telling, guys. So, all right, so let's go back to this and continue on. Here we go.
During the equinox, the sun rises due east and sets due west everywhere on the planet except at the poles. How could this be possible with your orange and plate theory? Sundials wouldn't even work, which would have been bad for people before we started using timepieces.
Okay,
totally
again,
Sundial, fine.
Yeah, sundials work fine, and again, the sundials have that same thing. When the light from the atmosphere, which is of course lensed, into this perspective dome, is hitting the sundial, then they work absolutely perfectly, no matter where you are. And what was the other thing that he said that I wanted to object to? I forgot.
But it's interesting too, Bob, that of course sundials are made by people who did not believe on a spinning ball. Like the Vedic, remember the one that you mentioned, the one from India, that's perfect to the minute, and it's all around the temple.
Yeah, exactly. And again, we know that this flat Earth delusion, this flat Earth psyop, baller psyop that is going on, has not come about but in the last 100 years or so. And you've got things like the Antikythera device, you have things like planispheres that have navigated successfully sailors all over the world for millennia. Come on, guys. That's the thing that is so amazing, that people can't see this. Now, as far as this whole the sun sets and rises everywhere on the Earth, directly to the east and directly to the west on the equinoxes. Jaron showed something that is mind-boggling on Google Earth. And Jaron, do you want to show that again, or the Google Earth thing?
Talk about the east-west being.
Yeah, I do. I think that's important. I think a lot of people don't realize that, because when you first showed that just melted my brain. I'm like, oh my God, that answers so much. So yeah, if you want to bring that up and screen share, we will flip it over to you and let you kind of go through that.
And while Jaron's pulling that up, guys, I've done star trails. If everything goes over this curvature of the Earth, why don't stars intersect the marine horizon they fade off into the distance above the horizon, and Globers will say, oh, well, that's the atmosphere. Okay, well, then how come that doesn't apply to your ISS, which is seen bright from horizon to horizon? So it's just more double speaklish from the globe community.
Yep, absolutely true. So, anytime you're ready, Jaron, with your... Oh, go ahead.
Yeah, the Star Trails should also be scrambling, right? According to their model, like they should never be perfect circles with the expanding universe and the other speeds and everything else. And nobody's ever been able to model that. So, yeah.
Yep, exactly. Okay, Jaron, you're Sharon, and you are presenting, sir. Except you're muted. Oh, Jaron, you're muted.
Sorry, now I'm back.
There you go.
Sorry about that.
Okay.
Can you see this white box or no?
Yep.
Yep, we do.
It doesn't show when I'm doing OBS, but I guess it'll show now. So really just what I think was so shocking to me is if you go to somewhere, anywhere, let's say here to the Monterey Bay, and you draw a line which would be 90 degrees east. Let's just go for 2,000 miles or so. So we're going to go to 90 degrees east, which coincidentally points almost directly at the equator there. Okay, so that line we know is 90 degrees east of this person. So if this person's standing here looking 90 degrees, they're looking here. So what you would then assume is that somebody standing here, west, where would west be for them? It should be here, right? And yet west, if you go to 270, would be down here at also 2,000 miles. So when you start realizing that the east and west aren't even the same for each person, and then really if you draw a line, let's say we draw a line at the this line here, and we just draw a line from here, and each of these people so-called see the sun rise at 90 degrees east, they say. So if you take a line from each of these spots and draw it at 90 degrees east, well, 90 degrees east to all these people is directly to the equator. So if you draw 90 degrees east to here, there, that's 90 degree up, 89, there, 90. So all of a sudden it just makes, you can start drawing lines from anywhere on this line and everybody's looking in the same direction when you go. So you can even just draw it to the equator right here and you'll know that you're close to, well, let's see here, where are we at? 90 there. So you'll see that everybody is actually looking basically in the same direction. Even if you go down here and show somebody looking 90 degrees here, again, oh, sorry, the equator's down here. I was thinking this was the equator. So this line would continue down to the equator. Obviously, if you started one here and drew it 90 degrees, it'd be the same thing. So 90 is about there. Again, it goes right to the equator. And actually, you can continue any of these lines. If you continue this line, so for instance, if I grabbed it here, oops, clear that one, grabbed it here and take it 90 degrees, it's going to end up on the equator. So stay right on that line and you'll see 90 degrees points directly to the equator. So east for everybody is not at all what we've been taught. If you ask somebody, oh, what's east of New York, they think it's over here, right? But if you take a line from New York and go 90 degrees east, you're going to end up down here. Let's see, 90 is there.
Yeah, and then show the converse, the flip side of that also, Jaron. Mm-hmm. If we go down to like one of the next major latitude lines and then go back west, and again, you would think that 270 would be, again, right back at the same direction, right?
Right, and 270 would actually be up here near the equator.
Again, yeah, so, exactly. Right. So that is exactly why that happens. Of course, when everybody's looking at really towards the equator and not true east or west, and that's actually what's happening. It's a no-brainer. And this is
not from the poles, because of course, if you go to the pole and you try and draw it 90, you're going to get a little bit confused because where do you go from here? But even just a little bit south of there, so say we go here and we say, sorry, where is 90 degrees from here? Well, it's going to be again way down here.
What is the angle to draw a line that corresponds to their latitude lines?
Well, there is no line like that. You mean the line of latitude here?
The ones they have.
Well, they're not going to let you draw a line that direction. There is no line that, if I draw a line from here to here, you'll see it arcs this way. It's not going to let you, it won't even let you draw that line. Now, again, the problem with this is where people get confused is if we know this direction is towards 90 and this direction is towards 90, still, if you zoom in and you get real down to the nitty gritty, you'll notice that this line is almost identical to that line, right? There would be no even, you couldn't even see that far. From here to here, that's already 30 miles. So how are you going to ever notice that you're not looking in the direction you think? Whereas this line, if continued on, would go all the way towards the equator.
But is it true that if you go 90 degrees, but then in small increments, then you have a different result?
Well, that's why east and west are circles. Because if you were to go 90 degrees, say we went 90 right here, okay, right to 90, and then you stop and save that line, and then go again, and you go 90, oops, here we go, and you keep going 90 again. Well, yeah, you'll just circle the Earth.
So it's different.
Right. You're constantly correcting. In other words, with respect to north, you are constantly correcting that vector, and people do not understand that.
No, the only thing that stays true is north and south, and that is explained perfectly on a flat Earth map.
Yeah.
Right. North is always at the North Pole. South is always directly behind north. So no matter where you go on this globe, if you point directly north, which would be here at 360, a little to the right. Right. Well, then obviously, if you're saying, okay, well, that person's north of me, well, then yes, it is true that that person who stands here, if they look south, look in the exact direction back. It's identical, 180. So that's explained perfectly on a flat Earth map, that north is always north of south and south is always south of north. It's a straight line. But east and west are circles, not north and south. North and south are cardinal directions, or actually north is, the cardinal direction, with south being the complete opposite. But east and west are not. And again, the easiest way to describe that is if you take a certain length of, stick, let's say you're at the North Pole and you tied a string to, how far is this? Let's go 1,000 miles. Okay, so right there I'm at 1,000 miles, right? Well, to stay that 1,000 miles, you make a circle. So a lot of people, you just have to go east. No, if you stayed directly east, you would go, let's say we were 1,000 miles out again here. And if you were to go directly east from that point, let me save that. Again, it's going to take you down which way? This way. So if you go 90 degrees off that point, then it ends up over here. We'll see where 90 is, this way. 90, which again will always take you towards the equator. So that's actually east from that point. So if somebody says, oh, well, I can just get in a plane and travel east, and well, if you get in a plane from here and you travel east, you won't come back around. You'll just go this way, south. And that's why any straight line is south. A straight line from anywhere on Earth will be south, other than if you're going directly north, obviously. But again, even if you go directly north, what happens when you cross the North Pole? Well, you're going south. So really, a straight line is in any direction eventually going to take you south. So that's basically it. But I mean, that was a big thing for me, is just learning. I mean, I would always think that, if somebody's directly east of me, I'm directly west of them. But it's not the case. Why? Well, because east and west are circles and don't go the direction you think they are. The only way you can say that you know where somebody is, if somebody is directly north of you, you are directly south of them.
David is strolling here with circumnavigation for dummies.
Yeah, that's actually a good thing to play, I think.
Yeah. Go ahead and take that over, Bob. I think I've...
All right. That sounds good. Now, guys, that was some serious gravy. When the first time Jaron ever presented that, I about fell out of my chair. I mean, I'm just like, holy Toledo. That's just mind-boggling. So, yeah, kudos on that, Jaron. That was just freaking brilliant.
Thank you.
All right, and let's see. Let me get my screen to the right place for you guys. There we go. All right, everybody should be seeing that. And let me go ahead and let me bring this up that David linked. And this is only a 2-minute video, so let's go ahead and play this to give you a perspective, a difference in perspective between the ball Earth model and the flat Earth model for those Globers out there that are watching. So flat Earthers, just be patient with us. Again, we're trying to convert some of the Globers, and they're watching. I guarantee it. So here we go. Let's take a listen to David's video.
Here's our flat Earth with our magnetic center. This is the shoreline that we call Antarctica that surrounds our world. And here's my boat. I put my boat down, and and immediately the compass points north. If I want to circumnavigate, I want to head west or east, but we're going to go west right now. So I'm heading west, and as you see, west keeps turning. So I have to keep going, and this is how, when you go west, you end up going all the way back to where you started from. Same thing for east. I go east. I keep having to turn because my compass keeps making me turn to go east. If I want to go dead reckoning west, so this would be dead reckoning west. If you watch the compass, I'm no longer going west, I'm going south. Any straight line on the flat earth will eventually become south. And that is how you circumnavigate on the flat earth. Nobody can circumnavigate south, because when you go south, you keep on going. Go north, and as I pass North Pole, I'm now going south, even though I'm going in the same straight line.
And what that kind of epic music is must be right. Right? I mean, how can they